Okay. So are you able to see my PPT? So maybe you can also do this problem along with me. Okay, you take a notebook. Okay, so just even as I'm discussing how to write an answer, you can also do the problem along with me. So the question is, write the converse, inverse, contrapositive, and negation of the following statement. Okay. So are you able to see my PPT? Is everything clear? PPT and my voice is audible. I have some response. Yes. Shashank, Shashank, are you able to see my PPT?
Yes, sir.
Oh, okay. So, so it's a simple question. So this kind of questions could be asked in MCQs, multiple choice questions. Okay. So here many okay, four answers are expected, but for multiple choice questions, we may ask any one of these. Okay, so say a statement would be given. You have to find the converse of the given statement, or inverse of the given statement, or contrapositive, or negation. Okay, so any one of these could be asked as a simple question. Okay, so what is the statement given? If Sandra finishes their work, she will go to the basketball game. Okay, so what kind of statement is this? What kind of proposition? Can anyone say what kind of proportion is this? Yes? What kind of proposition is given? Is there? Okay, I'm asking a very simple question just to find out whether people are following me or not. So people who generally don't answer just answer the question. So I find out who are all here and then we ask you to answer. Anas or here, can you answer the question? Anas, yes. So many people are here. Why don't you people answer? What kind of proposition is given? Sai Sanjana, can you answer me what kind of proposition is given? Sai, are you listening to the class?
Sir,
What
are
is
you free?
the proposition given? Are you able to see my PPT?
Yes, sir.
Yeah. Can you read the statement which I have given? What is the statement I have given?
If Sandra finishes her work, she will go to the basketball game.
Correct. Okay. Now, what kind of proposition is this? What is the name you would give for this statement, for this proposition? See, the statement starts with the word if, right? So this is a conditional statement, right? So Sandra, if she finishes her homework or work some work, she will go to the basketball game. Okay, so this is a conditional proposition. Okay, conditional statement. So, the type of statement given is conditional statement. Okay, so that's the basic thing you have to understand. So for this conditional statement, we have to write what is the converse, what is the inverse, what is the contrapositive and the negation. Okay. So before you write all these things, first you uh, use variables and write the given statement. Okay. So what are the atomic statements in this compound statement? Sandra finishes her work, then she will go to the basketball game. Okay, so how can you break it into smaller statements? How can you break this compound statement into smaller statements or atomic statements? Okay, so simple way is, so the first part, okay, Sandra finishes her work. Okay, that can be considered as yes, a sub-statement or atomic statement. Okay, then the next level, second, another atomic statement could be Sandra will go to the basketball game. Okay, so from this conditional statement, you can break it into two atomic statements or substatements. Okay, so let's name them as P and Q. Okay, so let P denote Sandra finishes her work. Q denotes the statement Sandra goes to the basketball game. Okay. So what is given is implication or a conditional statement. If P, then Q. If Sandra finishes her work, then she will. So then is understood. Okay. Then is not explicitly given here, but it is understood. Okay. She will. Then she will go to the basketball. Okay. So first to understand. So what is given is conditional statement or implication statement, and the notation for the given compound statement is if P then Q. Okay. Now what is the converse? Converse is very easy. Okay. So if Q then P. Okay. So that's the converse. Okay. So if Sandra goes to the basketball game, then she will finish her work. That's the converse. Okay. So uh, so converse from the given statement. Okay. So you just swap the conclusion as the initial statement. Okay, so Q was the conclusion and implication. If P, then Q. Okay, so you swap the conclusion in the first place. Okay, so Q comes in the first place and P goes to the conclusion. So that is called the converse of the given conditional statement. So if Q then P is the converse of if P then Q. Okay. So if Sandra goes to the basketball game, then she will finish her work. Okay. So converse of a conditional statement can be easily obtained by swapping the two atomic propositions. Okay. Now what is the inverse? Inverse of the given conditional statement. So what is the given statement? If P then Q. Okay. So inverse is simply you negate both the propositions given in the conditional statement. So if P then Q, okay, so you negate both the statements. So if you negate both the statements, it becomes negation P. If negation P, then negation Q. Okay, so that becomes the inverse of the given conditional statement. Okay, so to find the inverse, what you have to do is just negate the given compound statement. Okay, so you don't have to swap or do anything. Okay, just wherever uh, propositions, atomic statements is there, you negate it. Okay, so P and Q are there in the given statement, so you negate it. So when you negate it, it becomes negation P. If negation P, then negation Q. So if you read it as a statement, it goes like this: if Sandra does not finish her work, okay, so P is Sandra finishes her work. Negation P is Sandra does not finish her work. Okay. So if Sandra does not finish her work, then she will not go to the basketball game. Okay, so negation Q is she will not go to the basketball game. So Q is she will go to the basketball game. Negation Q is she will not go to the basketball game. So this is the inverse of the given additional statement. Okay, so so converse easily okay, can be obtained. Inverse also it just negate the atomic statements given in the question. That is the inverse of a given statement. Okay. Next one is contrapositive. Yeah. What is a contrapositive? So to find the contrapositive, what you have to do is you negate the inverse. Okay. You negate the converse. What is the converse? Converse of the given statement is if you then. Okay. You negate this converse. Okay. So when you negate the converse, you get contrapositive. Okay. So if so it becomes if negation Q then negation P. Okay, so this is the contrapositive of the given conditional statement. Okay, so how do you get the contrapositive? The contrapositive can be easily obtained from the converse. Okay, converse of the given conditional statement. So converse is Q then P. You negate this statement, it becomes contrapositive. Okay, so if negation Q, then negation. You see, so contrapositive can be easily obtained from converse. Okay, so you see so common things are there. So contrapositive is the negation of the converse. Okay. Right. So if you read it as a statement, it goes like, if Sandra does not go to the basketball game, then she does not finish her work. So this is the contrapositive. Okay. Right. Now negation. Negation is P and negation Q. Okay, so this is a negation of the given implication. Sandra finishes her work and she does not go to the basketball game. So this is the negation of the given statement. We can also think of what is contradiction. What is contradiction of the given statement? Can anyone guess what is contradiction for the given P and Q? So contradiction is okay. So I'll just write it here. So I'm adding one more constant. So what is the contradiction of the given statement? So if P then Q is the implication. So the contradiction is, can anyone guess what is the contradiction of the given statement? So one way of getting contradiction of the given statement is, okay, so it is using the negation P, okay, uh, and or the bit operation, okay, so P and negation P, okay, so P and negation P is a contradiction, or you can also have contradiction like Q and negation Q. So so you have Q and you don't have Q, okay, so you have and you don't have, which is a contradiction. So Q means what does Q refers to? Q, what is the given in the statement? Sandra goes to the basketball game. So Q is Sandra goes to the basketball game. Negation Q is Sandra does not go to the basketball game. So you have a statement, compound statement, which says Sandra goes to the basketball game and Sandra does not go to the basketball game, which is a contradiction. Okay. So for the given implication statement, the contradiction could be either P and negation P or Q and negation Q. Okay, either of them can be considered as a contradiction of the given statement. So are you able to understand how for a given compound statement, conditional statement, you can find all these things. Okay, so you can find um, in converse, inverse, contrapositive, negation, contradiction, all those things can be. Any doubt in what we have discussed? So this kind of problems could be asked in the multiple choice questions. Okay, so, so this will be included for the second internal. Okay, so in the first internal, the rules of inference. This topic alone was not included for the test. So this kind of simple problems could be included in the. You can expect in the second internal. Okay, now let me do one more problem. So with this, I will finish this unit. Okay. So the second unit will be over with this topic. I want all of you to do the problem along with me. Okay. So it's a word problem. You can all solve it together. Okay. So take a note. You can take a notebook. Okay. So follow the instructions which I am giving. Okay. So you can easily do the problem. Okay. So before doing the problem, let me recollect the rules of inference formulas. Okay. So already I have given these rules of inference. Modus ponens. What is modus ponens? P and if P then Q. Okay. So what we infer from this is Q. Okay. So P and if P then Q, then what we infer is Q. Next, modus tollens. Modus tollens is negation Q and if P then Q. So that what we infer from these two statements is negation Q. Okay, so that is modus tollens. Okay, right. So you have to remember these formulas and then apply these formulas in our problem. Okay. Then law of syllogism. Okay, this is very simple law. If P then Q and if Q then R. So then what we infer is if P then R. Okay. Then disjunctive syllogism or case elimination. Okay, disjunctive syllogism is P or Q and negation P. Then what we infer is Q. Okay, so this P and the negation P will kind of cancel. Okay, they negate each other. So what is our conclusion is Q. Then conjunctive addition. Okay, so conjunctive addition is suppose we have two propositions P and Q. These two propositions can be combined as P and Q, and you obtain a new proposition. Okay, so two atomic propositions can be combined to form a new proposition. That is called conjunctive addition. Okay, right. Then I want to introduce two more simple formulas. Okay, disjunctive addition. Okay, disjunctive addition. So conjunctive addition is P and Q. For the same P and Q, you can also write it as P or Q. Okay, so atomic statements can be combined to form new compound statements. Okay, so if P and Q are premises given in the question, you can combine these two atomic statements using the connector and OR. Okay, so when you use AND operation, it is P and Q. When you use OR operation, it is P or Q. Okay, so this is using if you use the connector AND, it is called conjunctive addition. If you use the operator OR operator, then it is called disjunctive addition. Okay, right. So this is commonly used operators, commonly used in rule of inference. Okay, so mostly in all the problems we'll be using this conjunctive addition and the disjunctive addition. Okay, and another rule is simplification, conjunctive simplification. So if you have P and Q, if you have a compound statement P and Q, from this compound statement I can infer that P is a statement. Okay, so I can infer key, that is called particularizing. So either I can infer key or I can also infer Q also. So if P and Q is there, then I can take okay, new statements as P as well as Q. Okay, so this is called conjunctive simplification. So this also could be used in the problem. So today I am going to use these rules and do a problem. Okay, so remember these rules. So I'm going to do a problem. You can also do it along with me in your notebook. Okay. So first read the question. Show that the following premises are inconsistent. Okay. So I have to show the following set of statements are inconsistent. Okay. So let me read the statement. There are four statements. If Jack misses many classes through illness, then he fails high school. Okay. So carefully read the statement. Initially it may look like confusing, but okay, if you read the statements carefully, you will understand. You can write it using variables. Okay, these statements you can write as a variable. Using the variables, you can write as proposition. So the first statement is if Jack misses many classes through illness, then he fails high school. Okay. Then the second statement is, so first one is a conditional statement. Okay. So actually the first three statements are starting with the word if. So these three statements are conditional statements. Okay. Okay. Second statement is if Jack fails high school, then he is uneducated. Okay. So clearly this is a conditional statement. Third one is if Jack reads a lot of books, then he is not uneducated. Okay. Fourth one is a so what is the connector used here? And is used. Jack misses many classes through illness and reads a lot of books. Okay. So the connector here is and, so it is a uh, conjunctive statement. Okay, so two statements are connected using the and operation. Okay, it is a compound statement. So first one you see if the clue is you have if then. Okay, if then is there, then it means it is a conditional statement. So here also you have if, okay, if then. So, so the first three statement is a conditional statement or implication statement. Fourth one is a and statement. Okay, so something like P and Q. So we have to name these statements. Okay, so you can give any variable, convenient variable, so as to remember the statements. Okay, so Jack is commonly appearing in all the four statements, so don't use the letter J, okay, to represent the statements. Okay. So when you give variables for the statements, it has to be unique. Okay, to be unique. So from each statement, you have to pick up some unique words, and the starting letter of those words can be taken as the variable. Okay, for example, the first statement misses classes. So that's a unique thing, a unique point in the first statement. So I can take the first letter of these two words, okay, and name this and give this as a variable for this statement MC. Okay, so I can give the variable MC. Okay, so what is the meaning of MC? Misses classes. Who is missing classes? Jack. Okay, so that's always understood. So it's easy to remember the statement by looking at the variable. So MC means misses classes. So if Jack misses classes, then what happens? Fails school. Okay, so the key thing is he fails. So let's bring the word letter F. So he fails in school, so we can now write it as F. Yes. So the first statement is written as MC. If MC, then F. Yes. So what is the meaning of this? If Jack misses many classes, or if Jack misses classes, then he fails school. Okay, simply you can do it like this. So this is the first statement. Okay. So now I want you to name the second statement. Identify the keyword in the second statement, and you tell me how we can write the second statement. Who will tell me? I want all of you to join with me in solving the problem. So whoever understood, you can answer my question. How do you name the second statement? Can guess some variables. I'll ask someone to interact with me. Maybe who will interact? Deborah. Deborah, can you answer me? Deborah, can you unmute? Myself? Are you listening, Deborah?
Sir, fails, we will take F,
Okay. Ryan,
and
Ryan is answering. Thank you, Ryan. Yeah. Yeah.
and for
See,
the
fails is. Hmm. Okay. Okay. Tell me. Tell me. Go ahead.
then we will use that if then symbol, sir.
Okay.
Then we will use uneducated as U.
Very good. Very good. Right. So, see, fails high school already we have named it as FS. The first statement we have already named it as FS. So we will use the same variable FS. So fails school. Okay. If Jack fails school, then he is uneducated. So the key word is U. Okay. You can have it U, or you can even have it UE. Okay. Uneducated. Okay. So UE stands for uneducated. Very good. Thank you. So this is how you define variables. So it's not necessary that you have to name it as PQ or yes, like that. Okay. So it is for our convenience only. We are naming the compound statements. Okay. So I am okay. This is a famous problem you see in all discrete mathematics books. Jack misses classes, he fails high school, he is educated or uneducated. What is the conclusion? Whether he is educated or uneducated, what conclusion we can draw from this statement? In fact, we have to show that this is inconsistent. Okay, there is a contradiction in this argument. Okay. Third statement. Who will answer? Who will tell me the variables for third statement? What is the keyword in the third statement?
So that's reads and books. So we can use a variable RB implies negation of U.
Very good. Very good. Very good. So RB reads books. So Jack reads books. If Jack reads books, then he is not uneducated. So you have to see the word here, not uneducated. So uneducated already we have named it as UE. So not uneducated means it is negation of UE. So that we have to carefully notice. So so if Jack reads lot of books, then he is not okay. Negation UE, not uneducated. Okay, right. Okay, good. Next one, last statement. The last statement is this is not a conditional statement. Okay. So who, tell me, Ryan. Ryan, you can complete it.
Yes, sir. For fourth one, missing classes, we will take MC, sir.
MC. Okay. Hmm.
MC and Smoother and lot books
Read
reads
is the
read
RB. RB is the keyword. Okay. So read books. Right. So this is the uh, symbolic representation. Okay. So this is what we call it as symbolic representation of the language. Okay. So MC. Okay. If Jack misses, Jack misses many classes and reads lot of books. So this is the symbolic representation of the given statement. Okay, good. So now I'm going to use, so these are the four given premises. These four premises are given. So from this, using these premises, we have to arrive at conclusion. Okay. Right. Now, let me, so you form a, if you're having a notebook, okay, so you form a table. So this has been already, so what we have discussed is there in this slide, okay. Jack, so Jack misses many classes, it's denoted as MC, fails school is FS, uninitiated is UE, reads a lot of books is RB. Okay, so we have the premises. Okay, these are the basic premises. If MC, then FS. So exactly same as I have. So it is UE, it's not UE. It's, so this is not EU, it is UE. Okay, uneducated. Okay. So now I'm going to put it in a table and do some uh, uh, application of the rule of inference. Okay, so I'm going to apply the rules of inference to the given premises. So first, what is given? Uh, Mrs. class. Okay, so I'm going to. You can also write along with me. So that Mrs. classes to illness and he fails. Okay, then he fails school. That is one premises given. That's the first premise. What is the second premises? So you form a table like this. Okay. So what are the premises given that you write it in one column? Okay. Then in the next column we will write what are the rules we are going to use. Okay. What is the second premises? Second premise is Fs. If Fs, then we Fs. This is how we actually solve the problems in the class. Okay, so you have to do it in a notebook. So all of you take a notebook, form a table like this, okay, and follow me in solving the problem. Then you can easily you will understand it better. Okay. What is the third premises given? Third premises is RB if RB then not UE. So first you write the premises next part. Okay, so if or if you read a lot of books, then not uneducated. Okay, so negation and negation you. Okay, so I'm just writing in words itself as I don't have a third statement. What is the fourth statement? statement is the AND statement, right? So the fourth statement is MC and RB. Okay. For AND symbol, I'm just using. So these are the four premises given in the question. Okay. So for these four premises, you have to apply the rules of inference. Okay. So now that I'm going to do it in the next step. So these are given. Okay. These are all given statements. So in the next statement, okay, I'm going to make use of the um, given statement. Okay. So what rules we can use? So what are the new premises we can find from the given premises? So one easy, so if you look at the formulas which I have given, so from you can see if P and Q is there, then I can take P. Okay, so this is called simplification. So if two statements are there connected by AND, then I can use the P. If two statements separately are there, then I can connect it by AND. Okay, so so I'm going to use the uh, simplification, conjunctive simplification for the fourth premise. Okay. So by conjunctive simplification. Okay. So by that rule, what is my new premises? My new premises is I can simply take it as uh, either MC or B. Okay, I'll take Mrs. as. Are you able to see the PPT clearly? So I am taking conjunctive simplification. So conjunctive simplification. So young Mrs. classes and read books. So and from these two things, so this is P and Q. This is something like P and Q. So from this P and Q, I am simply taking P alone. Okay, so that is conjunctive simplification. Okay, right. Next, so this is my step one. Okay, so this is my step one of the process of applying the rules. So previous steps are all given. Okay, so these are all given. So I am finding a new premises. Okay, from the fourth premises. From the fourth premises, I have found a new premise which I am calling it as fifth premise. Okay, and the fifth premise is MC. Okay, now I can apply uh, uh, 1 and 5. Okay, from 1 and 5, I can apply modus ponens. Okay, look at what is modus ponens. So I will show you what is modus ponens. Here, P and if P then Q. What is our inference? Q. Okay, so P and if P then Q, then my inference is Q. Okay, so I'm going to apply uh, using the fifth and first one, my result will be, my inference will be yes. Okay. So I will do it in the next step. So applying model to 1 and 5. So 5 is the new premise, 1 is the given premise. So applying modus ponens to 1 and 5, my conclusion is F, yes. I call it as 6 premise. Are able to understand? So, basically, yes. So I found the new premises. Okay. So by combining first one and yeah, right, 1 and 5. So what is 5? 5 is MC. Okay. 5 is simply MC. So using combining these two premises, I get a new premise which I call it as FS. Now I can combine second premise and sixth premise, and I can get a new premises as the same rule. Okay, I'm applying the same rule to. Okay, so I'm going to use sixth premise. Sixth is yes. Okay, so I'm going to apply modus ponens to uh, 2 and 6. What will be my conclusion? So 2 and 6, what will be, if I from 2 and 6, what I conclude is, I get a new premise which I call it as UE. Okay. So this is applying models, the same rule, models ponens to 2 and 6. Okay. Now, I'm going to apply 7 and 3. Okay, I'm going to apply the rule 7 and 3. Okay, what is the name of the rule? UE, RB and not UE. Okay. So, yeah. Okay. Yeah. So so 4 and 5 we got UE and we got UE, that is 7. Okay. Then the rule that we apply here is um, okay. Simplification again from 1. Okay, from 1 again I can take RB. Okay, so from 1 again I am taking so using 1. Okay, so using 1, what is 1? 1 is what is the statement? 1 is okay, 4. Here in our case it is 4. So I'm using 4 here. From 4, I'm going to already I have derived the new premises MC. Now I'm going to derive another new premise which is RB. Okay, so 2 minutes I will finish it. So this is again simplification group. Okay, so just like how I have obtained MC. Okay, so apply conjective simplification. So using conjective simplification, I get new new statement simply RB, that I call it as RB premises. Okay, right. Now I am going to combine RB and third one. Okay, so RB, if RB, then not QE. Okay. Another statement is RB. Okay, so that I am going to combine. So RB, if RB, then not UE, then I combine with RB. So what is my conclusion? It will be, so modus, this is modus ponens. Okay, so I will show you what I am going to do. So I am going to apply again modus ponens to, so applying modus, so the result comes in one step. So I am applying modus ponens to 8. What is 8? 8 is RB, and the next statement is third statement. Okay, I am applying this. Okay. So this is first statement. So I am applying. So this first statement. I am applying mod exponent rule to 3 and 8. So when I apply mod exponent rule to 3 and 8, okay, so RB, what is the conclusion? Not UE. Something similar to there also. MC, FS, MC. What is our conclusion? FS. So similar logic used here. So what is our conclusion? That I call it as 9, and the conclusion is not UE, not uneducated. Now, if I combine 7th and the 9th statement, I get a convolution. Okay. So that's the last step. Okay, I will include. I do not want to do it here. So now I am going to combine. Um, 7 and 9. Okay. So when you combine 7 and 9, you get a contradiction. So what is the contradiction? That okay, educated and uneducated. Okay. So disjunctive conjunction. Conjunctive addition. Conjunctive addition. Okay, so the rule I am applying here is conjunctive addition. So conjunctive addition is, so what I get is conjunctive addition is UE, okay, UE and not UE. So when I do the conjunctive addition, okay, of 7 and 9, 7 is UE, 9 is not UE. Okay, so when I apply the conjunctive addition to 7 and 9, I get a contradiction. Uneducated and not uneducated, which is a contradiction. Okay, so therefore the given set of premises is inconsistent. So are you able to understand? So this is how you have to construct new premises, okay, from the given premises using the rules of inference and arrive at a conclusion. Here the conclusion is the given premises is a contradiction. Okay, right. Okay, so I have taken additionally some time. Let me quickly answer your attendance. Number one is there.